Hello and welcome to Analytics Educator. Today I'm going to show you a case study where we'll be discussing how a company can formulate a business strategy to retain their employees. So we'll be using Python and couple of other machine learning and deep learning algorithms to formulate the strategy. So first let me show you the dataset which we'll be using for this particular case study. This is the dataset looks like. Let me increase the font size. And in this dataset we have our employee IDs, all different IDs, the number of projects they have worked on, their average monthly hours they have put into their work, the time spent, work accident in case there has been an accident, 0 and 1. 1 means there has been an accident, 0 means no accident, and whether they have left or not. So this is our dependent variable, so which we are going to predict whether the person has left. 1 means the person has left, and 0 means they have not left. Okay, whether they have been given a promotion, which department they are from, their salary, it has been categorized as low, medium and high, their satisfaction level, their last evaluation, all these stuffs are given. So with this data we are trying to predict, in case we get a new set of new bunch of employees, so we can predict whether they are going to leave or not. Okay, so let us go ahead and build this machine learning algorithm. So as I said, I'll be using Python, and this is a Jupyter notebook which I'll be using. So this is the description of the case which has been given. I'll also give you a link where you will get all the codes and everything. It is given in my website. In the description I'll be mentioning it. So let us understand how we are going to do it. First we are importing the packages what we will require, and import the dataset. And let me have a look at the dataset. So we have the employee ID and number of projects, and the same thing what we just talked about. But we can very well understand that these are the categorical variables, the department and salary. These are the categorical variables, and we can also just have a look. I have given the name of I have imported the data frame as main data frame, main df. You can use any name. We can just have a look how many values are there in here we just saw that using the Excel sheet, but in case I want to check that with Python, I can check that. Suppose for department, how many departments we are here, we can use the value underscore counts, and we can see this many departments are there. Okay, so we can later on, after doing it, we can fine tune it by checking the number of values in each department. But for the time being we will just create the dummy variables for each one of the individual department. Okay, so in order to create the dummy variable, we are going to use the pandas get underscore dummies. So for both dummy variable and the salary, these are the two categorical variables, we are going to create the dummy variable. And what Python will do over here, the alphabetically the variable which comes first, we can check it over here, the alphabetically which in department comes first, the accounting department is coming to be the first, so this will be considered as your base. So in salary also the high will be considered as your base, so it's going to be dropped, and for rest of the variables we'll be having our dummy variables. So let's create it. Now you can see, so for all the different departments now we have the dummy variables, they have been created except accounting, because that's going to be considered as your base, and similarly salary, low and high dummy variables have been created, and high has been considered as your base. Now quickly we can check for the missing values. Missing values, we can see there are couple of variables with missing values, but this is where we are getting the absolute numbers. We don't want to see the absolute number. Let's suppose we want to see the uh, in terms of percentage, which will give me a better understanding. So instead of sum, I can give it as a mean into 100, and I can see it's 0.18% and 0.18% values are missing. So it doesn't matter. So I can delete all these rows. So it's too insignificant to replace the values with either mean or median. I could have done that if they were more significant numbers. I'm going to just simply delete them. Okay, so this is the same thing. I'm not executing this one, so simply drop this one. Okay, now you can just have a look once again. Do you get to see any missing values? No, so everything is 0, so we don't have any more missing values. We are fine. Now we are going to go for the model building. So for model building, what we are going to do is, first, in order to do that, we'll remove some of the redundant variables what we had. Okay, so the redundant variables, I can just have a look. Df dot head. So I can see for the employee ID, it doesn't make any sense. It's just like a simple ID where everything is different. Okay, so certainly it's a redundant variable. So I'm going to delete this variable from my model. It's not going to be of any use. So simply drop this one. Okay, and now we are going to check in my dependent variable how many 1 and how many 0 are there. 1 means they have resigned and 0 means they are still working. How many of them? We can see there are about 11,000 and 3,500 over there. I can say normalize equals to true in order to get a percentage count. So we can see 76% are 0 and 23% are 1. That means they have resigned. So kind of a balanced data. So it would have been great if we had it 50-50%, but in real life rarely we are going to get a 50-50%. So it's a kind of a balanced data. So we are kind of okay with this one. I don't think it's going to create a problem for us. So just a way of checking it. In case it had it been an imbalanced data, then we could have gone for maybe smart method. Maybe I'm going to create another video on that for an imbalanced data. For the time being, it's a balanced data, so we are fine. So let's go ahead and what we are going to do is split. So we are going to drop the left column from the main data frame, and I'll name it as X. That's my independent variable. So X means all my independent variable, and I'll save as Y only the left part, that is the left column, that is my dependent variable. So my X and Y, they have been created. So I can just have a look at the X head. Sorry, this is a capital letter. I had written a small letter, so it's a uh, case sensitive Python. So these are all my independent variables. In X and in Y, I have all the dependent variables. Now we are going to split the data set of X and Y into 70% and 30%. And here what I have written is, these are the package which is going to required, and then I am giving 4 different names of different files. The X will be segregated into 70 and 30. I mean, similarly, Y will also be segregated into 70 and 30. So I am segregating them. Test train underscore test underscore split is the name of the function, and X and Y, which I had segregated over here, X and Y, and here test size equals to 0.3, means under the testing part I'll have 30%. I also could have made it as 2.2, that means 20%, 80% would have been splitted. 20%, 80%, 70%, 30%, all are very standard. You can just check any one of them, no problem. So they have been splitted out. Now for all the training part, I mean the x part, the independent variables, we are going to scale them because we can understand all the values, they are of different scales. That might not give us a proper accuracy, so it's better to scale them. So here I'm using a standard scaler. I am going to scale them. It's done. Now what I'm going to do is I'm going to use a logistic regression, because it's a binary logistic regression. So here these are all my packages which I will require. I can just show you uh, separately. These are all my packages which you will require. Execute them, and then over here I am naming it as model. Just write logistic regression, and then you model.fit. That means you are actually running the logistic regression on the x and y trend, x trend and y trend, that is dependent and independent variables of the 70% of my data set. So if you execute it, it's done. So my logistic regression is also done. Now we are going to check for our accuracy. Now based on this model, I will predict the holdout sample of x test, that is the 30% independent variable I'm going to predict. So I'm naming it as predictions, and once I have done my predictions, these predictions will be further compared with the y test part, the holdout 30% dependent variable, and I'm going to check how much accurately, whether I could accurately match the things where my model is predicting them to be 1 in the real scenario. In the y test, is it still 1, or it's 0? That means I have predicted it incorrectly. Okay, it's just like saying, probably you have understood. Just for my confirmation, I'm just showing you once again. So if this is my y test, where I had something like 1 and 0, something like this, and based on the independent variable I'll create a prediction. So where I'll also be predicting something like this. If my prediction and the actual prediction is matching, that means it's a match. If they are not matching, it's not matching, no match. So whether it's match or no match. Okay, so over here, how many rows do I have? 5 rows I have. Out of 5 rows, I could match only 2. So my accuracy will be 2 divided by 5, that is 40%. So let me see over here in actual, how much accuracy do I get over here. So I execute this one. I can say the precision and the recall. Precision means it's my model's precision. So for whatever rows my model had said 1, how many of them actually been 1? So I can say which is not a very good number. It's definitely not a great result. So there are about, out of all the 100 ones where my model has predicted to be 1, only 57% of them have been 1. Zeros my model could predict in a better fashion, which is 82%. Recall means out of all the ones in the entire dataset, I could predict only 35% of them, whereas 0 is much better. But we are not very keen on predicting the zeros, because anyway these guys will be retained. We are more interested to know who are the people who are going to quit. So this is not a great number what we are getting, and on an average we are getting still 78%, but I am not very happy with the precision and recall of 1. So let us see how we can improve it. Okay, so so much logistic regression can do. So how about we use a neural network, an artificial neural network? So let's see. So I'm going to import the packages for the TensorFlow, and then that's okay. If you're getting this part, it's not a problem. uh, and in artificial neural network, here what I'm doing, I'm using a sequential. You just give some name, classifier. I've given a name as classifier. You can use any name. Sequential, and then units equals to means you can use any number like 5, 6, 7, means it is the your first hidden layer you're using. As a tip, you can use any number, but as a tip I will say is the total number of dependent plus independent variables divided by 2. It's a tip from me. You can try that. I mean, there is no harm in using 9 or 11, but just for the starting point you can use this one. Okay, input dimension means how many independent variables do you have, and activation will be ReLU, and this is going to be uniform. Let it be as it is. So this is where I'm just going to introduce another hidden layer, and if you want to add another hidden layer on the top of that, means is the second hidden layer. If you want to use the third hidden layer, you can just use copy paste that, no problem. It's going to be a third hidden layer. But with these type of data, couple of hidden layers should be good enough. You don't need to have so many hidden layers. It should be fine. And then we are using the output layer, where we are using kernel initializer. It will be uniform, and for binary, a dependent variable is always going to be sigmoid, and the unit's always going to be 1 for a binary dependent variable. No need to change that. And I'm going to run this one, just run it, and then I will be here all my settings have been done, and now I'm going to compile it. I'll actually run it on my data set. So optimizer is Adam, which is going to be Adam will be using your stochastic gradient descent, which is presently we just want to use, and matrix will be accuracy, and loss is binary cross entropy. These are very standard for binary logistic regression. And on the top of that, we are also going to use a epoch of 20, means 20 repetitions will be happening. Okay, and we have also used a k-fold cross validation, means all my data set will be segregated into 10 different parts, where each part will be tested as a testing set within the training set. This is called a k-fold cross validation. For that, we have taken a 10% holdout sample, so that we can ensure there are no overfitting of the model, and we will be just compile and run it and see. So here for each epoch they are trying to do it, and the accuracy for here it was about 75, then 80, then 90, 92, 92, 93, 93. Gradually it is increasing. Okay, gradually it is increasing at the end of 20 epoch. So we know we have gotten the accuracy, which is not increasing any further. Or you can try it by giving little more epoch, maybe 50 or 100, just to ensure that we are giving sufficient time to model to train itself and give us the maximum result. And over here, let us check the result. By default, it's going to give us the probability. So here what I'm doing is, for the probability, if you try to check it, so only the y pred, what it's showing is it's giving me the probability values for each one of them. So we don't want to see the probability, otherwise it will be difficult for us to create the accuracy. So we want to just match it. So what I'm going to do is, I am using a numpy function to convert it. If my probability is 0.5 or more, I'll convert it into 1 else 0. Okay, so if I execute that, now we have all 1 and 0. Now again I'm going to evaluate it, I'm going to test it with a holdout sample of my testing part. So now this is my new prediction, which I've created with artificial neural network, and now I'm going to test them with the y test part. So let's check it, the evaluation. See, it has given me a much better result, significantly better result. So my 0, it has gone up 97 and 95, whereas 1, it has gone up to 84% and 90%. So overall 93%. So now I'm pretty happy with my precision and recall for 1. So earlier you can see over here, so it was only 57 and 35%. So a very low number, but now it has gone up to as high as 84% and 90%. which is pretty cool. So this is the power of artificial neural network. Okay, and you can get all this code and everything in my website. If you go here and you can type analytics educator, and you can go over here and you can go to the blog. In the blog there are different case studies which I have given, and you can search it by this name, retention study, figuring out which employee may quit, and here you get the same result. All the codes and everything, you can just copy it as well for your own use. With all my descriptions and my comments, everything is given. Okay, and you can further visit our site and to check what are the courses we offer as a professionally. If you want to check our courses, you can just go for our courses. You can contact us, and do let me know. Here I have also given uh, my email ID and phone number and WhatsApp number. If you want to have any comments, you can put it into this comment section of this video, or you can directly mail us or WhatsApp us or call us for any courses or any suggestions you want us to create for any other further videos. Please drop in a mail. All right, thank you so much. Hope you have liked the video. If you have liked the video, then please subscribe to our channel and share our video. Thank you.